Hi everyone, welcome to another episode of 30-day Leetcode challenge. I think we are closing in towards the end of the challenge, and at max, I guess there are two problems left. Luckily, it's been a good journey, and we have been on track on a daily basis. So let's get moving. Today's question is binary tree maximum path sum. So you're given a non-empty binary tree. You need to find the maximum path sum. So for this problem, a path is defined as any sequence of nodes from some starting node to any node in the tree along the parent-child connections. The path must contain at least one node and does not need to go through the root. Okay, so I think in case of 1, 2, 3, it's intuitive that if we include all the roots, this is gonna give us the maximum sum. Um, in this case, we are gonna take 15 to 20 to 7 tree because root basic, because if we, let's say if I take 15, 20 or minus 10 and my 9, this whole sum is less than 42. Similarly, 7, 20 minus 10 and 9 will give us a less sum, right? So let's look at the approach before jumping in. I'm gonna consider the case where I take this 15 7, right? So what we are gonna do is, obviously it's a tree based problem. Intuitively, I will go with the recursive approach. So we start at the root, right? And then before jumping on to the code, I'm gonna consider something as a max variable, max s, which is gonna be a global variable. Okay, now as I traverse through the tree, what do I do is, let's say when I reach the leaf node, I'm obviously the leaf node is the last node, so I'm just going to return um, the values of this leaf node. So let's say 15 and 7. Now the main thing to focus on is, let's say I am standing at this node, right? Now my left subtree gives me 15, right subtree gives me 77. So what cases do I cover? One case is that I take a cumulative sum of 15, 20 and 7, right? So one case is I just considers that some part of the left subtree. So here is the catch. I take this maximum sum just in order to track the max sum, right? So if let's say I had a case where this is something like 226 and then 27, right? And this became minus 15. So let's say this subtree gave me the max, right? Now what I'm doing is, while coming up, I'm basically going to return the sum of 27, 26 and minus 15 to 20. So this max sum is doing nothing but storing whatever is the max sum I have encountered. So this whole subtree, the left subtree is going to return the left subtree sum, and the right subtree is going to return the right subtree sum, right? Now when I'm at this node, I'm going to do few things. Obviously I can consider either the left subtree as a max, so I make a comparison of, in my max method, either I take left subtree sum or I take the right subtree sum, or I consider left subtree plus the root, right? So I consider left subtree plus root. I'm using the abbreviation RT for root, or I consider right subtree sum plus root, or I consider left subtree comma right subtree sum plus root, right? So these are the cases, and then obviously I compare it with whatever is my max s till the point after. So possibly max sum is this, so I might not consider any of these cases, but uh, my basic functionality while going bottom up would be I'll be returning, calculating the left subtree sum, calculating the right subtree sum, and then trying out these cases. So one of these could be a max, so I take that. So let's say this sum, whole sum, gives me 42, right? So my max s, let's say, is 42. So I return 42 back. Now at this stage I have again these cases, so either I take max of 9 comma, either I take max of right subtree is 42 comma, I take uh, left subtree plus root, which is -1, or I take right subtree plus root, which is -32, sorry, 32, and then I take a case where 42 plus 9, which is 51 minus 10, which is 41, right? Comma, I take max s, which is 42 itself. So I'm obviously gonna consider 42, right? So I guess this seems pretty clear and straightforward approach. I don't know if we're gonna encounter any corner cases, but let's jump on the code and see what can we get to work. I'm, as I said, I'm gonna use Java. Um, so it might take me some time to write Java code, but bear with me. So I'm gonna have, as I said, access is equal to 0, and then I just do public details, root, and then I check if root is a leaf tree, right? If root of dot left equals null, and so I just return the value, root dot value. Now in other case, if so I take two sum, 90 left sum is equal to 0, 90 right sum is equal to 0 if root left is not equal to null, so we are going to traverse on the left side. So left sum would be traverse root dot left if root dot right is not equal to null. So let's get traverse dot right, and then I'm gonna compare. Initially I can compare max s is equal to max, use max s comma left sum. Another case, I'm writing it in a different line so that our cases are clear. Right, and then just copy these lines. So one would be left sum plus root dot value, sum plus root dot value plus left sum plus root dot value 1, 2, 3, 4, 5. Let's say 1, 2, 3, 4, 5. Okay, so there are 5 cases. So I can remove this, and then obviously to the top I'll always what do you say, push or return the subtree sum, right? Because I'm anyways capturing the max s while going in the subtree through a global variable, so that is gonna take care of it. I'm gonna check if this is null itself, then just return 0, else we are gonna do traverse, and we just return max s because max s is storing the max value. Let's see, Let's copy if we can this input and see we get 42. Awesome. Let's submit it and see whether it works. Okay. Expected one. Okay, in case of one, okay, in case of one, it won't be null, so I'm gonna enter this. So, oh, in this case, yeah, we can check. Yeah, we would have missed this case. Yes, correct. Yeah, it's a good case. Okay, no answer. Yeah, traverse route is gonna give me back 41, but so I go over this. Let me do system. Got 42, 42, but then why are we not getting 42 here? This is interesting. Let's add this case here. I don't know why it's failing there. Interesting. Oh yeah, it could be negative number as well. Let's take this number and see. So we traverse, okay, if we traverse and then I'm at -2. So for -2, I have a left area, so I go to the left I return root dot value. So left sum is -1, and root value is -2. So I take. I think I should take it. Yes, because. Hmm. Let's see. Yeah, left sum is -1. Oh, max. Yeah, we need to assign them as well. This. Okay. Oh, we need to add a case where I take just the root as well, right? Like, I don't need to. Correct. Hmm. Yes, this will pass if I have 0 here, 0 here. I think it's waiting if all the numbers are negative, right? I guess I should get 15. Correct. Hmm. I know what to do, I guess. basically if this is not null, then we should put it here. No, why to compare them if it's if root dot left did not, then in that case I compare with this as well. Okay, and then this comparison. Okay, this is there, this is there, this root value will happen. I guess this should work. Awesome, I guess now if I run this. Okay, what is happening here is 48, right? Why 48? If I take 7, 11, 18, 22, 22 plus 5, 37, 8, 35, 35, 30, 48. Oh, this is happening. 48, it should go here rather than going. So, what is happening here is I should return max of this or max of this or max of this whole. I mean, basically these two included or these two included, right? If none of these, then yeah. Yeah, if I include these, then it forms a node, right? It should always be coming this way, or it's going, if these, because for this it either forms a continuous root in this direction, or it can form in this direction. It can't form like this, right? And what I'm doing is I'm returning the sum of this, so I should return so what does it say? So it could be because in that case either I can start with this node, or I can start with these two nodes. I can continue with these two, right? So this should be -1. Okay, this should be 48. I think awesome. It was a pretty good question. We struggled a bit, but we were able to figure out most of the corner cases. If you guys like this video, please subscribe to my channel and give me a thumbs up. Thanks everyone.